Hello all, I'm Manya Singh. So today we are going to discuss the topic harmonic function and the connection between harmonic and analytical function. So before knowing what is analytical function, we should know what complex functions are. So let's dive into that. So a complex function is a function that maps complex number to complex number, which is f is c to c. There is connection between c to c. So to know more about it, we'll be solving one question. So here I have taken one example, fx equals to z square plus 3z plus 2. So in complex number we know z is always equals to x plus iy, where x is the real part and y would be the imaginary part, which is with I would be always the imaginary part. So let's solve this. So we'll be putting z value in place of z as x plus iy in place of z square plus 3z plus 2. So it will be like x plus iy square plus 3x plus iy plus 2. Further solving these brackets, it would be x square plus I square y square plus 2x iy plus 3x plus 3iy plus 2. So here we know that I square is equals to minus 1. So we will be putting this value over here. So it would be x square minus y square plus 2xiy plus 3x plus 3iy plus 2. So all the terms which contain I would go into imaginary part and non-I would go to real part. So it will be like real part equals to x square plus y square plus 3x plus 2, and the imaginary part would be 2xiy plus 3iy. So basically we can not write I also, we can directly write it as 2xy plus 3y. So through this process we solve how to solve a complex function with the help of this. We can do more examples further, but for now onwards we'll be showing one example for this. So now we will learn what harmonic functions are. So basically a function u x comma y is a harmonic if it satisfies Laplace equation. So Laplace equation is given by dou square u upon dou x square plus dou square u upon dou y square is equals to 0. It should be always equals to 0. To know how it is, we will be doing one example. Here I have taken u x comma y equals to x square minus y square. So we'll see how it satisfies Laplace equation. So it will be basically like we'll first of all we'll differentiate with respect to x. So dou u by dou x. First order differentiation would be 2x, as we are doing with respect to x, and y is constant, so it will become 0. And if we double differentiate this thing, the same function, it will become 2 with respect to x only. Coming to dou u upon dou y would be x here is constant, so we can take it 0 minus 2y. And doing the double differentiation of this, it would be dou u square upon dou y square equals to minus 2y. And as Laplace equation says that if we put in the same equation these two values, so we will get 2 minus 2 equals to 0. So hence it satisfies Laplace equation. So we know that it is a harmonic function. So we'll dive into how it is connected to analytical function. So analytical function. So for a function to be analytical, we know it should satisfy CR equation, which is dou u upon dou x equals to dou v upon dou y, and dou u upon dou y equals to minus dou v upon dou x. And we should, if we are showing the connection between harmonic function and analytical, we should know what harmonic conjugates are. So basically, if a function f z equals to u x comma y plus bx comma y is analytical. Its real and imaginary part are harmonic. Here this function is harmonic conjugate. We call this bx comma y is harmonic conjugate. So to know how to find this harmonic conjugates, we'll be taking the same examples that we have taken for harmonic function. So we already know the value of here dou u by dou x, which is 2x, and dou v dou u by dou y, which is minus 2y. So going further into this, if we equate this with the CR equation that we have, so we can say dou u by dou x, which is equals to dou v by dou y. So we can also write this dou v by dou y is equals to 2x, as they both are equal. So similarly we can do it with minus dou v upon dou x. So minus dou v upon dou x will be minus 2y, minus minus if you cut, so it will become 2y. So further after this, we gonna integrate vxy. We can integrate it with respect to y also or x also. I'll be integrating with respect to y. With respect to y. So if we do the integration, and with respect to y, we see that it is 2x. So integration of 2x we will be doing. So it will basically be 2x, as we are going with respect to y, 2y plus c. A constant is added over here. Going on to next part. So this is the value of vx comma y that we got. So basically it is vx comma y is the harmonic conjugate of u x comma y. So we got the value of vx comma y, which is 2xy, and we already have the value of 2x comma y, which is this. So further putting this into analytical function, which was given by fz equals to u x comma y plus b x comma y. We'll be putting both the values in this, which will give us x square minus y square plus 2xy. Hence, it shows the connection between analytical function and harmonic function, as we have found the value of vx comma y, which is the harmonic conjugate of this u x comma y, and we have put it into the equation of this, and it is analytical, as we have already shown that it also satisfies the CR equation. So we can show the connection of harmonic and analytical function. Thank you.